We're looking at SAT scores, which we know are normally distributed. So again, make a quick sketch of that bell-shaped curve and just label your mean value, 1024, and then keep track of that standard deviation value somewhere on your paper. Okay, let's see. We want to know what SAT score represents the top 15% or is the 80th percentile. So 85th percentile, that's kind of high. That means that we're looking for an SAT score that's on the right tail of the distribution. An SAT score that separates the top 15%. So that means that this shaded area in red is an area of 0.15, which means that the area below it, which I'll shade here in blue, is the 85%. So that is 0.85. If you're using your graphing calculator, the function that we want to use here is the function called inverse norm. So inverse norm is what you use when you know the area to the left of the value that you're trying to find. So here, let's go ahead and type in 0.85. Or if you know the area to the right and you don't have the fancy calculator where you can choose left, center, or right, then you can simply type in 1 minus the area to the right, and your calculator is smart enough where it'll do the subtraction for you, and we know that that's 0.85. Okay, the next piece of information that we need to put in is the mean value, so 1024, and the standard deviation value, 229. If we press enter here, the calculator will give us an SAT score of 1261.34, which we can just round down to a 1261, okay? All right, if you're not using the graphing calculator, then what you need to do is you need to figure out the z-score that corresponds to an area of 0.85. So we would need to go to the z-table and figure out what that z-score is. Going to the table, we see that a z-score of 1.04 corresponds to an area of 0.85. And so then we can use that z-score and then use the formula x is equal to z times sigma plus mu. Making these substitutions, we can go ahead and multiply 1.04 times 229 and then add 1024, and that will also give us 1262, which is pretty close to what our calculator gave us. So any errors you get is just due to rounding.